In this project, I will demonstrate how to use incremental rotary encoder with FPB-RA0E1 board. Attach group base shield for Arduino interface on FPB board, then connect encoder with D6 and D7 pins. Although rotary encoder is connected through Arduino base shield, but baseline connection diagram is shown here. VCG is connected with 3.3 volt and ground is connected with ground. Signal A is connected with D7 and signal B is connected with D6 of Arduino interface on FPB-RA0E1 board. These resistors shown here have pull up the signal A and signal B. Later in the program, we will use falling edge interrupt detection. Open ESK Studio and click on File, then select New, then select Renesas C++, then select Renesas Array Project. A new dialog box will appear. You can give name to your project here. I am naming my project as Rotary Encoder. After naming your project, click on the Next button. Here from this drop-down menu, select FPB-RA0E1 board. After board selection, click on Next button. Here select Executable and No Autos option, then click on Next button. Here select Bare Metal Minimal and click on Finish button. ID will take some time to load your project. After project configuration, click on New Stack, then click on Input, then click on External IRQ. Click on IRQ stack, then open Properties window. Here we need to select the edge detection mode, pin and channel number for external IRQ. As we have attached rotary encoder with D6 and D7, we can use channel number 4 where we can configure P102 which is connected to D6 of Arduino interface. From this drop-down menu, select P102. According to Quick Start Guide document, P102 is connected with D6 of Arduino interface. We don't need to configure interrupt for D7. We will use that pin as input mode. By default, when project was created for FPV board, P102 was configured as input pin. Scroll up and expand P1. Here select P102. For GPIO mode, select disable option from this drop-down menu. Now recheck for P103 which is connected to D7 of Arduino interface that is configured as input pull-up mode. Now again open stack tab, then click on external IRQ stack, then open properties window. Now for trigger source, select falling edge detection. After that, you need to define callback function for external IRQ. We don't need to change anything further. Click on generate project content. Now expand SRC folder and open harlentry.c file. Now I am adding the Sagar RTT source code in this project. Now include common utils.h file in harlentry.c file. Now open FSV configuration file and click on this information icon for external IRQ stack. This will open FSV documentation related to external IRQ. Here you can study the example related to external IRQ stack. First we need to call external IRQ open function call, then we need to call external IRQ enable function call and the callback function example for external IRQ. This animation highlight the working of incremental rotary encoder. So if we are moving in clockwise direction, channel A will be pulled to low and channel B will be pulled to high, and when we are rotating it counterclockwise, channel A will be high and channel B will be low. In Project Explorer tab, expand Developer Assistant tab, then expand external IRQ stack, then drag and drop external IRQ open function call in harlentry.c file. Now declare FSP error variable. Now use assert function to make sure external IRQ open function call was successful. Now drag and drop external IRQ enable function call in harlentry.c file. Then use assert function to make sure API call was successful. Now I will declare a empty while one loop here. After that, from developer assistant tab, drag and drop external IRQ callback function here. Just for demonstration, I will implement the main logic in callback function. Now close external IRQ stack, then open GPIO stack. From GPIO stack, drag and drop pin read function call in callback function here. Now declare FSP error variable and use assert function to make sure pin read function call was successful. GPIO pin read function call requires symbolic pin name given in FSV configuration file. Open FSV configuration file and copy the pin name for P103. You can use this symbolic name in second argument of pin read API function call. Now for third argument we need to define BSP IO level T variable. You can type BSP underscore IO then press Ctrl plus spacebar to get suggestion related to predefined macros. For third argument in pin read function call, you need to give the address of BSP IO level variable. Now in global space, declare this counter variable. Now if control have reached the callback function, we have received the interrupt on D6 pin. Now we will check the pin state of D7. According to its pin state, we can know the rotational direction of rotary encoder. In if condition, you can increment the counter variable. Now use appprint function to log on RTT terminal that rotary encoder is rotating in counterclockwise direction. Now in else condition, you can decrement the counter variable and use the appprint function to log on RTT terminal that rotary encoder is rotating in clockwise direction. Now use the appprint function to log the counter variable on RTT terminal. Now you can build your project by clicking on your project name, then click on this hammer icon to build your project. After a successful build, right click on your project name, then select debug as, then select NSS GDB hardware debugging. After that, IDE will ask you to switch to debug perspective. Click on switch button to switch to debug perspective. In debug perspective, click on this resume button twice, then open RTT client terminal software. Now if you rotate rotary encoder, you can see the updated value on RTT client software. So the benefit of using the interrupt approach is that if the processor is busy in another task like the while loop we declare in our program, but the interrupt will always be serviced by ISR, interrupt service routine. When using sensors that rely on human input, it is always advisable to use interrupt. If processor was busy in blocking delay or busy in another task, then you can miss on some of the user input. Also for demonstration, I have used the callback function to check for D7 and use the appprint function. But in production code, keep your callback function instructions as minimal as possible. Like in FSP documentation we studied earlier, just set the variable flag and run the other instructions in HAL entry while one loop.